Hi everybody, welcome back to the third segment of our presentation in a series of lecture using hyperspectral imaging and multispectral imaging in quality evaluation of agro-food products. As you saw from last video, we see how the configuration of the system consists of how we can acquire an image and what is the difference between hyperspectral imaging, color imaging, multispectral imaging, and what is the main differences between all of these different technology. In this session, we are going to speak after you acquire the image, how you can deal with this image. What are you going to do with the data you extracted from the image, from one image, either from color image, from multispectral image, or hyperspectral image. So in this slide, you can see here we have different data cube coming from different samples. So after you acquire the image, you need to extract data, and this data you need to go to the computer. And from computer, you can think about different scenarios. You need to make something like image pre-processing, to make calibration, to make segmentation, to develop multivariate modeling, to make classification and prediction. All of this should be carried out in the computer. And from the computer, you can represent the resulting data in different scenarios. Like here, you can put the data in the form of spectral data, like table X and Y, to plot your data, to show the binary image from different products, to see some pseudo color image, to see the classification map or chemical image. As you see here, how to differentiate between spot to spot in the same object. This is a scenario you need to put in your mind all the time when you deal with information coming from hyperspectral imaging. In general, if you need to deal with the hyperspectral imaging or multispectral imaging data, there are three modules you need to put it in your mind. The first module is to acquire the image in proper way, and then make some pre-processing and the calibration of your image. The second module is to extract the data. So once you have a good or a high quality image, so that means you have a high quality data. The third module is to build the model. So what you need to see by your eyes from the data. So good image lead to good data, and the good data will lead to good model for classification or prediction of the quality attribute you need to see from your object. Finally, you can build, as you see here, chemical image. Chemical image means you can see chemical information that you are unable to see by your naked eyes. So to develop this kind of classification and the chemical image, you need to be equipped with some information and some background about multivariate data analysis technique. So if you need to make classification to see your object is good or bad, is diseased or not diseased, damaged or undamaged, so you need to use classification models. And the classification model could be supervised or unsupervised. And supervised, a lot of technique, and from unsupervised, some techniques. If you need to predict something inside your sample or your product, you need to use regression model. From regression model, there are also linear model or non-linear model. Under non-linear model, you need to consider some models, and on linear model, you need to consider some scenarios to predict some attributes inside your sample. These are some examples coming from different references. As you see, these guys try to predict the sugar content in melon. This from our work. We try here in this work to predict water content, fat content, protein content in fish and meat product. And in this application, this guy tried to show the chlorophyll content distribution inside the tomato at different maturity stage. A lot of applications is available using multispectral imaging and the hyperspectral imaging, but there are another technology we didn't speak about. It's called illumination-based multispectral imaging. We are going to speak about this technology in more details in the second session. See you.